Yeah, hi there. Good afternoon. It's the Thomas time slot. It's Dave Thomas speaking downstairs and me here standing in front of you. And welcome to my session of how testability supports your agility. I know I'm between you and the beer, so let's start with a TL'DR, and then you can decide if you want to take the beer early. What are we going to see in the next 35, 40 minutes? Testability and how it supports your agility. What is agility in software development? It's about delivering software continuously and about to easily and quickly adapt to change. And this requires some form of safety, for example, by a safety net of fast test automation. There are other safety measures, but this is one safety net that we need. But that's really difficult if testability isn't built into your code and your architecture, if code and architecture aren't designed for testability. So I want to show you one pattern of promoting testability by separation of integration code and domain code, because I think it's a really fundamental aspect. And this will be a pretty detailed example because it fosters, in my experience, the discussion, the thinking about testability. You needn't follow that example I will be showing you, but it fosters discussions about testability in code design and architecture. And one thing to note before we really start, the ideas I will present to you aren't really new. But from time to time, I think it's necessary to talk about these basics because these basics are still essential and they may be 20 years old. But more and more people are entering our industry and they may have never heard of these aspects of the basics behind this. So I'm going to present you some really basic stuff, but maybe you can need that, reuse that in your company to motivate other people to think about testability. And maybe this basics about testability are more essential than 20 years ago because now more and more companies want to become agile and deliver software continuously. All right. Now, you know this game. If you've got any questions, please go to Slido, and we're upstairs in the machine house. You will see the QR code at the end again. So let's start. Why do I want to present? Why do I want to talk about testability? That's me. I'm a technical agile coach, and I'm working for Die Techniker, TK, which is Germany's largest health insurance company based in Hamburg. And before that, I've been to other companies and I've seen lots of monoliths, self-contained systems, microservice architectures along the way. And when I go to teams as a technical agile coach, we code together, we do some refactorings, and we do pair programming and mob programming. And in all teams, I meet the different aspects of agility, architecture, and testing. So, a quick poll at the beginning. I've replaced the middle with coding and agility with agile with a uppercase A. And just let me know by raising your hands, what do you consider yourself mostly? Who would say I'm an architect? Very few, okay. Who would say I'm a tester? More testers than architects. Okay, who's into coding? Who's a developer? Half of the people? Okay. And who might be like an agile coach or scrum master or this? Okay, third. And let's see if that sums up. Okay, and who would say I'm into more than one role? A quarter of the people. That's great because, you know, when we want to deliver software continuously with a safety net of fast tests, we have to collaborate. We cannot do this alone. But all too often, these roles work too separate. And when I come to those teams, typical situations are we aren't agile enough. Whatever that means, if it's from management or from the teams themselves. The customers aren't satisfied because we don't deliver value and we don't see any progress. This can be from management, from the customers, or from us developers. If we don't see progress, that's really frustrating. And here's my observation, and typical symptoms of those teams, maybe, in my observations, they have no tests. Or they have only manual or mostly manual tests. And manual testing is slower than everything that you automate. Or you've got slow automated tests because you do mostly UI testing using whatever tool. Or you've got fragile, unstable, flaky tests. Tests that fail for some reason and you spend lots of time investigating why those tests fail. All those symptoms make you slow. And now here's my findings or my claim. Teams with fast test automation are more agile than those without. What does more agile mean? They deliver more often in smaller batches and so on. We've heard about that today. And they can write tests more easily. That's my claim, my observation. And you can ask, is this a symptom or the cause? But there are so many talks about that agile is the cause and tests are the symptom, that say just become agile and everything else will follow. So let's just assume for this talk that it's the other way around, that if we have fast tests, the safety net of a blazingly fast test suite, then we will become agile somehow or continuous. Let's just assume it's the other way around, because I've been to too many agile teams that haven't been agile at all, that didn't have a fast test automation, that didn't deliver value continuously. What makes those teams more agile? Let's have a look at this dev team. They've got a fast feedback loop. They're collaborating, maybe doing team programming, mob programming, or pair programming. They've got fast local tests. And multiple times a day, they commit their changes. They commit everything they did, and some automated build server builds this. Maybe every commit, maybe multiple times a day, and there is no manual interaction. Lots of automated tests, and we've got an automated gateway that says when it's green, okay, we can deploy to the next stage. I've called this some pre-stages like developer integration or acceptance stage. And in these stages, we have mostly automated tests and a mostly automated gateway before we can deploy to production. And it's your choice, and it's an architectural choice. If you say we want continuous deployments, that everything is automated, every commit goes to production, or if you have continuous delivery and you have someone sitting there and doing the final decision of deploying to production. Everything is okay, and all those teams are pretty fast in delivering software. Okay, who of you delivers software this way? Say multiple times a day to production. 1, 2. Really cool. I've been to such teams and that feels really good. Who delivers once a day to production? More? Who delivers once a week? Okay. And the rest once a month? Okay. So only few of you deliver that often. But I think it's a goal, and we've got lots of automated tests here that help us do this way. How dare they? How dare you? Delivery multiple times a day to production. I mean, we've got processes. We cannot deliver every commit into production. What about quality? What about tests? Well, they've got those tests. They've got a safety net of fast, predictable, and a comprehensive test suite. So we know if a test fails, it fails for a reason. And it's fast and comprehensive. And they deliver value continuously in small batches. And if something goes wrong, we know what went wrong and how to fix it most of the times. And that makes us developers happy because we see progress, and our customers are happy because they see progress. And we dare to make changes because we've got those safety net of lots of fast automated tests. And that's pretty agile. And if you noticed, these icons were from modern Agile. So that's not only pretty agile, but actually pretty modern Agile or modern software engineering. So everything you've seen here is, in my experience, often the best way to build software delivery today. Not in every case, but it's a good aim to start with. But it's the result of evolution. those teams that delivered this way started small, and it evolved, and they've got lots of freedom and some guidelines. They've got an architecture that supports their tests and their delivery. For example, something like a macro architecture and a micro architecture with some guidelines. Do you want to build a temple or a city? And a micro architecture where you can build different houses, huts, funny houses, and maybe even houses that you consider not worth pursuing, and we got to tear that down. So you've got some guidelines how to develop and lots of freedom to experiment, to try things out. And these architectures, these ideas behind architectures, support delivering software. What is architecture anyway? There are different views and that no clear definition. Let's stick with this definition. I'm not sure if Martin Fowler coined that one or just promoted that one. Everything that's hard to change. We've heard this morning that this is already a legacy statement. But since not all of you are delivering continuously, maybe it helps us, this view helps us. So everything that's hard to change, all the decisions that need lots of rework afterwards once we finish them. And testability is a property of your architecture. So if you do some decisions for your architecture and you don't have testability in mind, it might be hard to build it into your system later on. But how to decide which decisions to take? And let's have a quick look at some general principles, really old ones actually. The aspect of structure and design. I think they are 60 years old or 50. That's high modularity. We don't have a big ball of mud. We have smaller modules. We have strong cohesion. Everything that belongs together is close together. We've got loose coupling. Everything that doesn't belong together is farther apart. And we've got information hiding. We don't expose details that others cannot depend on this. And these are architectural aspects. How do they matter for testing speed? Where do we talk about these aspects? For example, when we separate systems into smaller ones, the size of systems, the dependencies between those systems, how they communicate. These are the places where you usually talk about monoliths, monoliths, self-contained systems, microservices, and so on. But these factors also affect the local dependencies within one system. Not only the broad external architecture, but the architecture within one system. And let's put the focus today here. And I'd like to focus on one aspect, one pattern, the separation of integration code and domain code. And I'd like to show you an example, a deeper example into this, as a way to start thinking about testability. And the great thing about separation of integration code and domain code is it makes for a solid foundation of fast tests. And it's a local decision to your service, to your product, to your application. And it's possible to do this in legacy systems too. And once you learn how to build testability into older systems, maybe your next system you build from scratch will have built testability right in from the beginning. Don't know about you, but I need an example what I'm talking about. Okay, this is a common real-world example that you will find in many companies. I'd like to call this disrespectfully a flow heater. If there are some German speakers here, Durchlauferhitzer. It's a flow heater. We get some input, do something with it, and put it somewhere. It might seem trivial, but many softwares are based on this structure. All right, but in this simple example, we've got lots of dependencies. For example, the file input format, or the input format of the data, the database schema. You're dependent on this, and this is a heavy dependency. Maybe you're dependent on the persistence framework and the entity representation. You will not store your data directly to the database. Why not? Well, you're dependent on a persistence framework. You're dependent on some other framework, for example, for the REST endpoints or whatever you will be using. And does someone see the other dependency where some place left? Do you have an idea? I think that's our business requirements, and we're dependent on them too. It's a different kind of dependency, but we don't code the validation and transformation, whatever, for our own fun. We've got some business requirements to fulfill. And the problem is dependencies are often beyond our control. And what's beyond our control, it's difficult to test. And every dependency is a reason for changes. And changes break the code, and changes break the tests. So if we minimize dependencies, we minimally break the code, that's okay, code will change. But if we minimize dependencies, maybe our tests will break less often. What and where can we test? Looking at this process, I can test everything end to end. That's the hardest part, because I've got lots of dependencies to test. I can do some integration testing, maybe all the integration I need, or just one parts of this. It's easier, but still both ways are hard and usually slow to test because we've got too many dependencies. And then we've got the unit and component testing, or say the testing of our validation and transformation. And this one usually can be fast. And the trick will be, if we take these ideas of what's hard to test, what's slow to test, let's take as few dependencies as possible, and let's test the maximum scope that's possible. So let tests break for as few reasons as possible, and let's test here as much as possible, because we need to test some form of integration. But I like to test all of my business code, or as much of my business code as I can. Now, in the ideal world, we've got clear responsibilities. We've got the business logic, let me call this the domain code, and we've got external systems, and in between some integration code. And this might be easy to test because we can test all the things separately, but dependencies sneak into our domain. And then we've got to test our domain code, including the domain. And if you don't take care, the sneaking goes on, and you've got dependencies that you didn't know about. Let's have a look at some code. So let's look at this validation and transformation. I'll leave out the database, and I'll use some pseudocode. Only a few of you were coders. Let me try to explain this to you that it's easy to understand. I've got some function here, validate and transform, and the input data is a JSON entity. JSON is some format of transporting data. And then I want to validate some business rules in our JSON entity, transform some values, say, have a customer number, and transform that to a new scheme. And then I want to save this in the database, but before I can do this, I have to map the JSON entity to the database entity. Pretty simple code, and I hope you can see the distinction between this green code. This shall be our domain code. Now, the domain code is separated from the integration code. The JSON entity and the mapping and saving to database, that's integration code, and our domain code is here, separated from the rest. Oh no. Have a look. We pass this JSON entity here. That's the integration into the outside world. And when we pass this to our business logic, suddenly our business logic becomes entangled, intertwined with a real-world representation. And that's a dependency that may be hard to test. Maybe not JSON, but you get the ideas. You have dependencies where maybe you don't see them. Nobody would code like this, right? We all do. And it's our decision if this is a good idea. We just must be aware of these dependencies. And if this is a one-time transformation, this may be the perfect code for this. But if you work in an enterprise and this transformation becomes part of larger process pipelines, it will live for years, for decades. So it may be a good idea to separate this and to make it better testable. So let's just do some refactoring, and let's extract this business code into a separate function. So I've got this validate and transform, and I've got the domain code. You will find a better name for this. I've got this domain code, and the outer function calls the domain code and passes the JSON entity. Step one. It's already separated, but still we depend on the JSON entity. My domain code still is not free of dependencies. And now I change the JSON entity to a domain entity, to a new domain entity that belongs to just our domain code. And now we can write fast unit tests, lots of tests, including all the edge cases for this code that's free of any dependencies to the outside world. And the only thing that's necessary is we have to map our outside world to the domain entity before we can work with it. So there are some further steps necessary, and it's our decision if we want to work like that, because if it's worth testing this separately with lots of fast tests. And the longer you use this, the better this will help you for your test safety. You will need some integration tests for the rest, but maybe only a few ones. Maybe, say, the happy path or an error case, not all the edge cases. And this might be a simple example just for where dependencies lurk, how to detect them, and how to get rid of them. And you will find these patterns everywhere. What we just saw are some code design patterns and styles, and I showed you some idea of the integration operation segregation principle. There are other principles that support this form of separation, like the single layer of abstraction, and these patterns usually are associated with clean code. Please don't make an ideology, this clean code thing, but there are some good patterns that we can make use of. Just use it as a starting point for discussions. And these patterns we also find in architecture as well. We will have some architectural styles and patterns. Let's have a look again at the broader view. Now, what if our domain code isn't coupled to the input data and to the database, but we've got some interface that says just get the input from somewhere and just save the output to somewhere. So we are not coupled, bound tightly to the real world. Then we can put test doubles here. Might have heard of mock objects, dummy objects. Let me call them test doubles, because later on we might have fake objects here, and too much buzzwords. Let's just call them test doubles. And we can suddenly have fast unit tests for the complete use case of your domain code, of all of your domain code. And when we want to integrate this into the real world, we have adapters, for example, a Postgres adapter or an Oracle adapter, and we've got a client adapter for the input data. But we can test our domain code without the real world. Now, if I reshape this diagram and make this a circle, and the adapters somewhere out there, and then I put some ports here, you may notice the ports and adapter architectural style or architectural pattern. That's a pretty common pattern, how to separate the external world from our internal domain code. As I said, this is the ports and adapters architectural style, sometimes called the hexagonal style or hexagonal architectures, because sometimes it's drawn as a hexagon, but it doesn't say anything about the number of ports. So let's just keep it a circle, and you have as many ports as you like, as many input and output ports as you like. And there's an extension to this, which I like even better, and it's called the onion style architecture or onion style architectural pattern. And there they put some more onion skins above each other. And the idea is, if we hear domain code, most of us think in domain entities and, let's say, database tables and so on. It's not about that. The whole domain is more than that. It's our business logic without the database. And the idea of the application is that we have complete use cases. All of our workflows, all of our processes written in code separate from the real world. And sometimes we have even more onion skins here. But the basic idea is to even have more skins than just the domain code, that we have some core domain that we talk about, and then all the use cases that we code, that we program with it. And we can test and use this complete application without the real world. Now, what does it give us? let's just look at what we've just seen. The idea of hexagonal ports and adapters in onion style is to have dependencies allowed from outside to inside only. This means we've got no layers. Do you know layered architectures like front end and back end, or above and below? And that's often not helpful for architecturing modern systems, for testability. And onion-style architectures and ports and adapters, they think of outside and inside. The external world and what I control. And dependencies are allowed from outside to inside only, to the stable domain core from the unstable external world. Often you read the external world is more likely to change. The domain is stable, a complete stable domain is less likely to change. And yeah, we find justifications for this. But in my experience, we get business requirements and my application is changing all the time. Because business requirements changing is our day-to-day work. That's why we are software developers. So is it really about change or more about control? And control means if I can control it better, I can test it better. And maybe this means the outside world is less under our control and our inside domain and application is more under our control. And when we've got that under control, we can test it better. That makes for better testability. So maybe the outside world isn't changing that much, but if it does, it's often a disruptive change, like replace your database or you move from, say, AWS to Google Cloud or anything like this. So the changes are more disruptive, and still we want these dependencies from outside to inside only, that we're not dependent from the outside world. How does it help us with testing? If you now remember that we've got complete use cases here, our complete application, if you will, and we've got these ports and the adapters to the real world. Now, if we write test doubles, test implementations for all the ports that we have, and we place those test doubles inside our application, we can have a complete fast test for our whole application. And this is the idea of, often it's not the idea of unit tests. Unit tests are often thought too small, but we can suddenly have a fast test of a whole application because we do not depend from the outside world. This will not give us a perfect safety, but maybe that's good enough. Maybe we've got 90% safety by those tests, and then we've got to test the other 10% by integration tests. And if you learn to code like this, learn to think like this, it will give you a better testable architecture. So patterns and styles for testability. I showed you some ideas for the code, some ideas for the architecture. My intention was not that we focus so much on the structure, but more on the ways of thinking. What's outside, what's inside, what's beyond our control, what's under our control. Because what's inside was what is under control, we can test far better than if we have to test the whole world. And if you do this way of thinking together, you can learn how to build software with testability in mind. It's always a question, how do we get testing into the mind of our developers? Talk with them, architects, agile developers, even agile coaches. Talk with them about dependencies and how to manage them, how to identify them, and how to make clear what's inside, under our control, and what's outside. And it's easier to grasp. Easier to grasp than what? What I've left out of this talk so far was TDD. Are there any agile developers here, XP practitioners, for the example? Or one or two, okay. I'm an XP practitioner by heart, and my response before I tried to teach things like that to people would have been, why not do it TDD all the way? TDD is a way of thinking to make software testable. then we get just enough tests. When the tests are passing, we're done. We may even delete some tests that we don't need anymore. So we've got just enough tests, and if we start with tests, they will be fast probably. So why not do just TDD? And yes, it's a code design technique. It's no testing strategy, it's a code design technique, and it will make your code testable. Yeah, you start with the tests, and probably your architecture will be testable too. But, and I must be careful, as a coach, must be careful with the word but TDD is not the goal. We want to deliver software continuously and safely, with a safety. And TDD can be really hard to grasp. And if you don't take care, it may seem like an ideology, like only TDD is valid. If you don't do TDD, it will not work. You cannot write tests without TDD. That seems like an ideology, and you lose lots of capable developers that would really love to learn how to write, how to make software testable. And the schools of TDD can really be confusing. I don't know if you've read something about TDD, but this inside out, outside in, London, Belfast, and Berlin, and so on. It can be confusing, and it needs experience. And that's good. You need to build experience, but you have to understand that not all the colleagues, all the developers have that experience. And this experience is especially needed if you build your architecture using TDD. Those different styles help you to take care of the architecture, but if you just do TDD without thinking about architecture, you may get a random architecture, and that's not a good idea, I think. So TDD is a really useful tool, and I like to use it really a lot. But if you want to convince others that this is the way to go, even for testability, please motivate the why. Explain why it's helpful to structure code in certain ways, and then use TDD as a means to achieve the how, to achieve the implementation. Okay. Do I have 3 more minutes left? Then 1 or 2 bonus. If you're into TDD, if you're a TDD practitioner, learn how to use TDD not only for microtests, what we usually think of unit tests, one method or one class. Learn how to do TDD for fast tests for your whole use cases. And this is what behavior-driven development aims at. And if I understand TDD correctly, that's how TDD was intended in the first place. So learn how to test your units with fast tests, and your units may be larger than one class. There may be complete use cases. That's a bonus if you're already in TDD. And when you've structured your code, how to keep testability in your code. And that's a sneak peek. I don't know, a sneak peek into a talk tomorrow. You could test your architecture. You can build business functions for the core ideas that you've identified, like dependencies from outside to inside only, or no framework dependencies. And there are suitable tools for this, like ArcUnit, which I like a lot. You can write code, Java code or .NET code, and have your fitness functions executed as part of your test suite. And this may be your first step towards an evolutionary architecture that Rebecca was talking about this morning, that Pat will be talking about tomorrow. And I've looked at their website. A second edition of their book will be out next spring, I think, and I've seen ArcUnit mentioned on their website, so maybe they will be talking about ArcUnit as well. Okay, a short wrap-up. Testability at the speed of light. Testability is a property of your architecture. So you have to think the same about testability as about your architecture. And it enables a safety net, and that promotes your agility. And please learn together how to build software with testability in mind. Don't say just write all the tests, justify the why, talk about the why you want to do this, and give some examples, for example, by separating integration into main code. Explore the freedom of design choices that you have, even in monolith, even in legacy applications. That's where architects can help. They can moderate the discussions and showing where teams are allowed to change, to choose something. Start where you are. We are not always on greenfield. We've got brownfield every time. But you can start separating integration code and domain code step by step. You get the people with you. You don't say, it won't work what you're doing. Let's look where you are and start from there. Pretty lean, by the way. And I cannot close this talk without this one. Please collaborate. I'm a great fan of coding architects, that architecture is a team sport, and that we all together define our architecture, and we all must be capable about discussing about architecture, and we can help us together in doing so. I'm a great fan of team programming, mob programming. We can code together, take our architects from time to time into our team and learn from each other how to build testable architectures or what the problems are with our current architecture, why we cannot test it. Some further reading. I will tweet the slides so you can look that up later on. Some old books, some really current books, I think, from this year, Modern Software Engineering by Dave Farley, which I really like a lot. But effective software testing is a read worth as well. Then, let's talk. I think we've got some minutes left.
Thank you first. So there are two questions. I'll give you one here, and the other one I think you should respond to in a tweet because it's nitty-gritty technical, so I don't think it makes much sense.
Let's listen to them both.
But the first question is, where are the product designers, the product managers, and the product owners in this beautiful Venn diagram? Somebody got forgotten here, Mikael.
Yeah, let me just go to this Venn diagram. I think it's somewhere there. This one, yeah. Let's take this one. I could put much more roles in there. I had to leave some roles out, like product owners, like managers, who have to give some space, who have to understand this as well. This talk was focused at how to build testability into your architecture. And there we need the architects, the testers, and the coders. And the people that try to help them getting their software done, which are, in my experience, Agile coaches or Scrum Masters. We need the surrounding organization. And what I'm not talking about here is what we do at higher levels for agility. And we need the understanding that testability is a quality aspect of our software, that we shouldn't let our users test the software. Or if we do so, that we have a good observability and we do not deliver software at once to 100% of our customers, like Henry releases, who was talking about this earlier today. So there are lots of roles missing if you go into your complete organization, into complete product development, and the products are left out purposely to keep the time.
Yeah, so the other question, which I'm not sure whether you can answer right now, is where would a method shown in the example be located in the onion? Isn't save to DB not going from inside to outside?
Does someone dare to give some context? Let's just have a look. I'll show you the onion in a minute. The question was if we've got, and correct me if I'm wrong, if we've got the save to DB here, this communicates with the outside world, so it shouldn't be part of the onion because it's not part of our core domain. And you're absolutely right about that. This is not part of our domain or application code. And maybe some save function. Yeah. Yeah. Okay, which slide do we take? take this one. It's a different way of coding, actually, which I learned by applying event storming in DDD, and we were building some scenarios from it. So we had some idea what we want to code, and we were like doing TDD as if you meant it. We were writing code that didn't exist. We said like, save this domain entity to somewhere. So save it to somewhere, and the port, the interface, if you think in coding subjects, the interface is part of your application. We said save to somewhere. And the save to database, this is part of the adapter. Now, we don't test, if we test this, we don't test the saving to the database. We test the saving to somewhere. And what helps if you do it this way is if you, let me use another slide with the test doubles. These test doubles, are you into coding and into this thing? If we put mocks here, mock objects or something like that, it will not help us. But if you fake these objects and you do as if they were working actually, but it's a much more simplified implementation, often it gives you enough safety. It's not a perfect test, but often it's enough safety. So let's say if we've got an adapter to the real database here, we might have an in-memory database, or even simpler, just a map that can store things and can retrieve things, a very simple implementation that helps you test your complete use case with the knowledge that this test double isn't perfect at all. But yes.
Then I go into the domain and gather feedback from inside the domain, where to put the now cold adaptive safer. Because this is going from inside cloud size.
No. The diagram might be confusing. The port is actually part of the application. The port is part of the application, and the save to database is part of the application in this port. And here, some form of choreography takes place, the use case that we say, take a domain entity and save it to this port. And the port is part of the application, and there we don't have clear dependencies, what one can use or not. So maybe I should put the port into the application completely. And the test double next to this. This was just because there was space, but you're right, the test double is an implementation of the port. Both belong to the application, and I should term them that they are on the same level of dependencies.
I think what's a little bit confusing is that then you have the save method, but the entity comes from the domain. And from what I understood, there should not be a dependency.
Yeah, the entity comes from the domain, and I'm point of the object. Part of the database adapter next to it. And then finally I have to call in the adapter from the point safer.
No, we don't call, and I think we should do this maybe later on because it gets heavily into detail.
Very good idea.
But you wouldn't call from the application into the adapter. You just call into your port, which is part of the application. So the testing really stops here, the domain testing or the fast testing, and everything else would be integration testing.
I think we have to thank Thomas now, and then you can have a discussion afterwards. Thank you, Thomas.
Thank you.